Hi everyone, Jackson here from SIG Machine Learning. Welcome to our next episode of Smart Control in Practice. In this video, I'm going to take you through a comparison of PID control versus smart control. In our previous video, we introduced the concept of smart control software. We discussed the how and where it fits within the different layers of an industrial operation, and we also communicated the value that smart control can deliver by significantly reducing the time it takes to make decisions. Today, we'll take a look at smart control in action via our Nextioneer platform, and using this comparison, we'll take a look at how the smart controller would have done things differently to the PID control. This comparison will help us highlight where the smart controller has helped us to reduce our operating costs by preventing failures, enhance our production performance by maintaining asset reliability, and improving our engineering efficiency by providing visibility and oversight. Firstly, let's break down what we're looking at here. The following trends are of an operating gas well. Each trend is showing us data from telemetry, and these trends can be grouped by production rates, operating pressures, and other critical telemetry, all of which helps us to understand the current and historical state of the system. Now you note on the pump speed signal here in yellow, it's oscillating in a PID loop. This PID controller has a pre-configured target to help it optimize the system by controlling the pump speed. There's just one small problem. The PID controller is not aware of some anomalous events that are occurring, namely, our pump speed is ramping up, leading us towards a failure. On the other hand, the smart controller is supervising in open loop, meaning the recommendations are being made to the smart controller, but not being actioned. This means the PID control remains as the primary form of control, but we have visibility of what the smart controller would have been doing differently if it were the primary controller. Now the smart controller is generating these set point recommendations at a given point in time. These recommendations are in the swim lane below, where yellow depicts a speed increase, navy blue a speed decrease, and the grey shading represents no action recommended to the controller. Now what I'd like to highlight here is the PID controller is leading the system towards a failure. The result of this is a significant financial impact due to the asset becoming inoperable, production rates ceasing, and a further need to replace the damaged equipment. So the final question is, what would the smart controller have done differently? Prior to the failure, there was a series of speed decrease recommendations to help offset this uncontrolled ramping behavior and rapid reduction in pressure. This provides an example of how a smart control system can be deployed to supervise existing controllers to identify set point adjustments that can maintain production performance and help prevent failures such as this. In our next episode, we'll be looking at an example of how a smart controller can help to support the dynamic optimization of an asset. In the meantime, if you'd like to know more, please reach out to the team. Bye for now.